Okay, so in this video we'll look at the log scale, a log graph. So it's a semi-log graph, only one side is logarithmic, the other side is linear. So if you look at it, you have 1, 2, you have about 20 points between 1 and 2, 20 points between 2 and 3, and after that it's more like a regular graph where there are only 10 points. Let's see what we can notice about this. Okay. So the first thing is that the gaps decrease, right? They get crunched in as the numbers become larger. Okay. So let's try to make sense of that. Yeah? So let's take 2. So 2 is here. So this is a double. From 1 to 2 you have doubled. Right? So 1 you were here, 2 you were there, you have doubled. So if I take a divider, for once we are going to use a divider. You see, from here to here, if I take a divider, then if I put it at 2, then because this is a logarithmic scale, I should get its double. Ta-da, I get to 4. You can't see it too well. Let me see if I can zoom in. There you go. Now you can see it. And that's 4. So if I put it on 4, same divider, I should get its double. You see? 8. And if I put it on 8, I should get 16. And that's where it gets interesting. So there we go. Okay. So if I put it on 8, it's telling me that that point is 16. There. Okay. So that's 10. So then there will be, since there are 20 points, it's like 10.5. So I have to count every other square. So that's 10. That's 11. That's 12. One skip. That's 4. That is 11. That is 12. That is 13. That is 14. That is 15. And yes, that is 16. Okay. So this is a 16. This point is a 16. That didn't really, there. And this point is an 8. This point is a 4. Oh. And this point is a 2 and this point is a 1. So when you look at it, the distance, which is a multiplication in the log scale, is constant. And that's what the logarithmic scale gives us. It gives us that if you want to multiply two numbers, you just need to add their lengths. Okay. So let's say we take a and the way it is organized, it will always say 10, 10, 2, 3, 4 only. Oops. It will say 10, and then again it will say 2, 3, 4 only. This means 20, this means 30, this means 40. The entire patch from 1 to 10 can be repeated. Okay. So let's take a larger number and see what happens. So let's say I take 32. So that's here. Okay. So this length 32 is this whole length, right? And if I did the same, my divider is still set. So if I just use this, it should give me double, right? And if I look here, approximately I get around 64, which is giving me till here. Oh, this has got only 1, 2, 3, 4, 5. 5 steps. So just the first 2 steps, which is where it came, that itself is 64, whereas this was 32. Okay. So but what is 32? 32 was from 1 all the way till here, like that. That is 32. Well, that's, yeah. And 64 is basically that. So as the numbers get larger, they get more packed, as you can see. Okay. And this is used for in a variety of ways. This idea is used with instruments earlier. Before we had the calculators, we used to use we used to basically have the log scale, and we'd have an instrument that you can move, and where basically you put the numbers and then you add them together and you get their product. So that was the idea. So I was able to get, I've done all powers of 2, so it's not that you can only do powers of 2, you can do any number. So let's take 40. So it's here, right? So this is, if you can see, 40. Okay, so now same idea. If I just take its double, yeah, then I get 80. Okay, so we've been able to double. Let's say I wanted to triple. Okay, so if I want to triple, then I need the distance from here to there. So 3 times, so that's 1. Okay, yeah, maybe a little less. So that much, yeah, that's from here to there. So if I took any number and I said I want to triple it, right? So let's say it's 16. I want to triple 16. Right here, right there, what? Okay, let's take 32, right? We said this was 32, not that, yeah, that is 32. And if I triple it, so I'm coming here. So that's like a 96, which seems right, yeah? So basically this means 32 times 3, which is 96. So this is the advantage of a log scale, that anything that you add becomes a product. So now we just want to look at what this means for a GP.